Alright, so in this video I'll be going over the 2019 College Board FRQ for APCS, and the problem is called LightBoard. So the LightBoard class models a two-dimensional display of lights, where each light is either on or off, as represented by a Boolean value. You will implement a constructor to initialize the display and a method to evaluate a light. So here they basically outline the class for LightBoard, and they're giving instructions for each component of the class. So here we're going to be having a class variable. It's a private variable and it is a two-dimensional array of booleans, and we're going to be calling it lights, and it gives two characteristics of this 2D array. So if the lights on the board are on, then it's true. If it's not on, like if it's false, if it is off, then we would assume that it is false. The value of that cell is false. And then here we're going to have two parts, main parts of our class, the constructor. And that is what we're going to be implementing in part A. And it gives the instructions here. We're going to be receiving two parameters, num rows and num calls. Now that is the exact dimensions of what we will be constructing our 2D array with. And it's going to give some preconditions, and obviously when you're doing programming, you should never assume what the user is going to input. You always have to account for you always have to set preconditions. All right, and another post condition is basically what we're going to be outputting, how we're going to be doing this, and that is to determine if a light is going to be on or off when we're creating our lights variable. There's a 40% probability that we're going to be turning it on, or if we're going to be turning it off. So that is what we're going to be getting to in part A. So here's the problem. Write a constructor for the LightBoard class which initializes lights so that each light is set on with a 40% probability. So there's basically a 40% chance that we'll be giving it a value of true, and a 60% chance that it will be giving it a value of false. So the notations RC represents basically the array element row R and column C. Basically that's the cell we'll be accessing. What they're implying is that when we're looping through, they kind of want us to use a similar notation, or they want us to use that notation to make it clear to the AP reader. Alright, so first we're going to start off with our method signature. Sorry, this is not a method, don't confuse. This is a constructor. This is the signature of our constructor. And why is it a constructor? It's not returning anything. We're just creating our class variable. So it's going to be public accessibility. We're going to be calling it LightBoard, obviously. That's our class's name. And there are two parameters, num rows and num calls. And the first line in our constructor should be creating our 2D array. And the reason why we're doing it here is that because we're receiving our parameters here. So now we're creating our lights 2D array with these dimensions from our parameters. All right, next we're going to be, whenever we're going through a 2D array, we're always going to be using a nested loop. So here we're going to be looping through our rows. So R equals 0 to lights.length. And lights.length, what does that represent? That basically represents the number of rows in the array. And next, inside that loop, we're going to be having a sub loop of int c equals 0, and c is going to represent our columns. And c is less than lights 0.length. So now why is this different from what we have over here, lights 0.length and lights.length? Well, what it's saying is, what is the length of this row? So basically, yes, technically each row can have a different length column, but in APCSA we're going to be generally we're going to be dealing with a set number of dimensions. It's not going to be that weird. So yes, each row has the same length column. So we're just going to pick an arbitrary number, 0. But to be safe, you can replace the 0 with R, so that every time we loop through, we're going to be using that specific row's column length. All right, so we're going to be incrementing our row, and every time we do that, we're going to be incrementing our column from 0 to whatever the length is. Alright, and the last part is actually giving each cell a value. So lights RC represents the cell or the current element in the 2D array that we're on. So it takes the row that we're on, it takes the column that we're on, and assigns it a true or false value. Now, and the reason why we're doing math.random is less than or equal to 0.4 is we want to create a probability of like a 40% chance that this value is going to be true, and a 60% chance that RC is false. And why are we doing this specifically? Well, math.random returns a value less than 1. So obviously, it returns a value from 0 to 1. So that value, if it's less than 0.4, it's going to be less than 0.4 theoretically 40% of the time. So that's why we're doing this. And if this statement here is true, then we're just going to be giving it to the cell. If it's false, again, we're going to be giving it to the cell value. So, and the reason why we can do this is because this whole expression here from math.random is less than equal to 0.4 is this is a Boolean. Like, this statement will either be true or false. That's why we can do this. Or you can write a conditional. Either way is fine. Alright, so that was part A. And that was the easy part because part B actually escalates. And this is very common in APCS. The difficulty, the intensity of the problem escalates a lot. But it's good because you can build some confidence with the easier problems like part A. But part B is kind of different. So part B says write a method evaluate light which computes and returns the status of a light at a given row and a column based on the following rules. So looking at this, you can immediately tell that part B is outlining the algorithm for us. It's kind of walking us through the problem. So the first step in the algorithm they gave us is if the light is on, so we're going to assume that if the light is on, if the cell value is true, return false, but only if the number of lights in its column that are on is even. So let's say we're going to be checking this cell here for evaluate light. For the first step, first of all, if the light is on, right? So let's pick this step. The light is on here. Now, if the number of lights in its column that are on is even, so let's go ahead and count the number of lights in this column that are on. So this is 1, and all these here are off, but then again, this one is on, and then off again, all right? So what was our count? Well, we counted 2 cells to be on. So now let's go back to our steps. So if the number of lights in its column that are on is even, is 2 even? Yep. So now, and it's telling us to include the current light, which is this, which we already did. So since the number of lights that are on are even, then we're going to be returning false. But you can't forget this cell, that current one that we're on, also has to be true. Okay. And if the light is off, return true, but only if the number of lights in its column that are on is divisible by 3. So let's look at an off one, for example. This one's off, right? So now let's go ahead and look through the column here. This one is on, this one is off, and this one is off, right? So we got 2 for a count that are off. But that's not what we were supposed to do, right? We're supposed to look at the number that are on. So don't get tricked just by the fact that they're asking us if the light is off. So look for the number of true values, all right? And looking at that, we're going to be getting 5 for our count. Now, is 5 divisible by 3? No. So this condition is pretty much not satisfied. And the last condition is like a test case that accounts if these 2 conditionals fail. So if both of these 2 fail, then all it's saying is return the light's current status. So let's say we're on this element here. If this element here did not satisfy these 2 conditions, we're just going to be returning the light's current status, which is true, right? We're just going to be returning the value of the element there. And what they do that is really good and helpful is that they actually give test cases and an example. So you don't want to get right to coding, right? Let's say you're stuck on the problem, you don't even know how to implement it. You can look at this example, look at the test cases, and then try to formulate your answer for the code, which is really good. But other than that, if you're actually doing the problem and you have a lot of time left, this is a great tool to actually test your code by hand, right? And they give you 4 test cases right here. All right, now moving on to creating our answer. So we're going to start off with the signature of our method, which is evaluate light, and we'll be returning a boolean in this method, and the parameters that it takes are row and column, because we want to look at that cell. We want to analyze that cell and the column that contains that cell, right? So the first step that they actually didn't give, if you look back, they give 3 steps, but we're missing a critical step that these 3 steps rely on. They always refer to the number of lights in the column that are on. They didn't tell us how to get it. So that's what we have to do. Before actually going to these steps, we have to count how many are actually on in that column. We were subconsciously doing it, but the computer needs instructions to do it as well. So that's what we'll do for step 0, let's call it. We're going to create a counter variable, and it's called onLights count in column. So the naming convention is weird, but you have to be specific as possible for the AP reader to understand. So what I'm saying is, in this variable, the number of lights that are on and the count of that. So the number of lights in this column that are on and whatever the count of that is, that's what this variable is keeping track of. Now, so far, it's going to be 0 because we haven't actually checked anything. We haven't checked if any of the lights are on. So next, that's what we'll be doing in our loop. As we go through our loop, we'll be incrementing as we go. So we're going to be going from r equals 0 to lights.length. We're going to increment our r variable. Now we're going to iterate through it, the row, and the conditional is set to check the value of the cell. So basically, we want to count only the on lights, right? So that's what it's doing. If this cell is true, this conditional is satisfied, and it'll go ahead and increment the number of on lights. All right, so that's the first step. Now with this part, we're going to be getting our count, which we can use for our later steps. All right, and then the next step is whatever the value of lights is, right? If lights is on in this case, and if the number of on lights in this column are divisible by 2, because that's what the instruction says, right? If the light is on, return false. But first, you have to check if the number of on lights in this column are even. So what they're doing here is kind of tricking you, right? You're probably going to read up till here and stop. Oh, I know what to do if I want to return false. You have to read on because they could be tricking you with the order, the sentence structure of this algorithm step, right? So that's what we're going to be doing. If it is on, we're going to check if the count is divisible by 2 and ultimately return false. We're not done there yet. We still have 2 more steps to go. This is our second test case, right? So if it is off, right? And that's what the else does. So let's go back to here. If the light is off, return true. But only if the number of lights in its column that are on is divisible by 3. So let's see if we're doing that. Right. So else basically accounts for the fact that if this is true, then this is else. This condition is going to be satisfied automatically. Now, the else is a complement to the if conditional. All right. Anyways, if the number of on lights in this column is divisible by 3, and the way we're doing this divisibility check actually is using the mod operator, right? The mod operator returns the remainder of a number divided by another number. That's the specialty of mod. And the mod, it can be used to actually check for divisibility, which is what we're doing. If the remainder is 0, then it's obviously going to be divisible by whatever number this is. In this case, 2 and 3. All right. So if this subcondition is met, then we're going to be returning true. All right. But if that doesn't work either, if these 2 first steps don't work, we're going to have a last we're going to account for the one last test case, right? And this is how we're going to do it. If none of these conditions are met, we're going to resort to our last and third step, which is return the value of the cell. So if the count is not divisible by 2 or 3, and if this primary condition is not met, then all the the instructions are saying is just return the value of that cell. If it's true, we'll just return it. If it's false, return that as well. So as you can see, we have to build a fundamental knowledge of 2D arrays and conditionals, right? So checking conditionals was a very big thing in this problem, but also knowing how to iterate through a loop, through not just one loop, through a nested loop for a two-dimensional array. And one thing I'd like to point out is the probability check. This one, it stumps some people, and that the reason why is because they don't know the functionality of math.random. They don't use it. And I'm pretty sure this math.random function is on the formula sheet for APCSA, and it shows what parameters it will take, which is none, and it'll show what its functionality is and what it returns. Alright, so thanks for watching. That's all I have today for APCSA.